we will be discussing some of the applications of Pythagoras theorem. So just a reminder, if you are given a right angled triangle, so right angled triangle is any triangle with one of the angles as 90 degrees. So let's say this is the 90 degrees angle. Okay, the side opposite to that is called as the hypotenuse, and let's say its size. Length of the side is C, and this is B, and this is A. So if you're given the right angled triangle, according to the Pythagoras theorem, the square of the hypotenuse is equal to a square, the square of the other two sides. So square of the hypotenuse is equal to the square of the other two sides. So how can you use to solve some problems? Okay, let's take a couple of examples. Let's start. Suppose you're given a rectangle. Okay. A, B, C, D. And let's say one of the sides is 8 units and the other side is 6 units. Okay. So you're supposed to find the length of the diagonal AC. Okay. So how do you find the length of the diagonal of this rectangle? As you know that in the rectangle, all of the angles are 90 degrees. So this is 90 degrees. So obviously this is a right angle triangle. So triangle ADC is a right angle triangle. So triangle ADC is a right angled triangle. You can see ADC, the right angle triangle. So that means this is the hypotenuse, and let's call it as C. Let's call this as B, and let's call this as A. So this and this are 6 units, this and this are 6 units. Okay, AD is equal to BC is equal to 6 units, and DC is equal to AB is equal to 8 units. Okay, so according to the Pythagoras theorem, for triangle ADC, we can write C square, which is the square of the hypotenuse, which is also the diagonal of the triangle, is equal to A square plus B square. Now we know that A is 6 square, and B is 8, so 8 square. So therefore 6 square is equal to 36 plus 64 is equal to 100. Okay, so therefore C is equal to 10 units. So that gives you the diagonal of the triangle, or of this rectangle. Okay, that's one use. Okay, on a triangle, we don't know what kind of triangle it is. Okay, and let's say A, B, C. Okay, and there is a perpendicular line from the point A to BC. Perpendicular means this is 90 degrees, and let's say BC is like 6 units again, and the perpendicular line cuts it into half. So let's say the perpendicular line cuts it into half. Okay, so that means that this is 3 and this is 3, and you're given that this is 6 units as well. So you're supposed to find AD, what is the height of the triangle. So we know that this is 3, this is given, and this is 6 units. Okay, so how do you find that? We know that this is right angle, so obviously this is C, this is B, this is A. Okay, so we can write C square is equal to A square plus B square. We know that C is 6, so there's 6 square is equal to, we don't know the A, so A square plus B is 3 square. So 6 square minus 3 square is equal to A square. So that's 36 minus 9 is equal to A square is equal to 27. So we can write A square is equal to 9 into 3 multiplied by 3, or A is equal to square root of 9 multiplied by 3, or A is equal to 3 root 3. So that's the height of the triangle when you're given the other two sides, the hypotenuse and one of the sides. So we can find out the other side of the triangle. Okay, that's another example. Let's say you're given a cube with length of the side as 1. So a cube is, you have seen a Rubik cube, right? So it has 6 sides with each side being a square. So there are 6 sides in the cube and each side is a square. And let's say for example purposes, the length of these sides of the cube is 1 unit. So each of these sides is 1 unit. This is 1, this is 1, this is 1, this is 1, 1, 1, 1, 1. Okay. Now there are certain sides which are hidden behind, which you cannot see from the front. Let's draw that. Okay, let this be A, B, C, D, and let this be E, F, G, H. Supposed to find the diagonal of the cube. So that's AG. Let's want to find the diagonal of the cube. So that's this length AG here. So what is this length AG? How do you go about this? So let's look at the bottom surface here. This is a square with sides 1, because all of the sides in the cube of equal length, or all of the sides in the cube are squares, and each one is of equal length, and in this case each of these sides is like 1 unit. Okay, so let's look at the square here, and let's draw the diagonal DG for this one. Okay, we know that this angle is 90 degrees because in the square all of the angles are 90 degrees. So this will be the hypotenuse. So let's call this as C, the length DG. So DG will be equal to C in the right angle triangle, and DC is equal to 1 and GC is equal to 1. So DC is equal to 1 and GC is equal to 1. So let this be A, let this be B. Okay, so we can write DG square is equal to DC square plus GC square. Okay, which is equal to 1 square plus 1 square is equal to 2. So DG square is equal to 2. So therefore DG is equal to square root of 2. Okay, that's the diagonal C. Okay, now consider the triangle ADG. Okay, let's say this is the triangle ADG. Okay, now this is, we know that angle ADG is 90 degrees. Angle ADG is equal to 90 degrees. So that means that DG is equal to hypotenuse. Oh, AG is equal to hypotenuse. Okay, which is equal to C in our case. And AD is equal to 1 and DG is equal to, we found that out. So AD is equal to 1 and DG we just calculated as root 2. So we can write AG square is equal to AD square plus DG square, which is equal to 1 square plus square root of 2 the whole square, which is 1 plus 2 equal to 3. Therefore AG, which is the diagonal of the triangle of the cube, is square root of 3. So we can say that AG is equal to square root of 3. Okay, we can say that. So that's how we calculate the diagonal of the cube. Let's say instead of length 1, if we are given a length of 2 for the sides of the cube. Okay, so each of the sides of the cube has a length 2 instead of 1. And the sides are 2 units instead of 1 unit. So let's say it's 2 units instead of 1 unit. So we know this. This is okay. A, B, C, D, E, G. Okay, so this is 2 units, 2 units, 2, 2, 2, 2. All the sides are 2 units. Okay, let's draw the diagonal for the base surface, DG, and find out what's the length of that. So we know this angle is 90 degrees. So we can write DG square is equal to DC square plus GC square based on the Pythagoras theorem again. So that's 2 square plus 2 square is equal to 8. It's 4 plus 4, which is equal to 8. So DG is equal to square root of 4 into 2 is 2 root 2. Okay, so that's this length, DG. Now let's draw this again, line here, which is the diagonal AG, diagonal AG. So let's change the color a little bit. So we are supposed to find the length of the diagonal AG. So we know, okay. So we know that AG square is equal to AD square plus DG square, okay, which is AD is 2 units, so 2 square, plus DG square is, we just calculated that 2 root 2 the whole square. So that's 4 plus 8 is equal to 12. So AG is equal to 4 multiplied by 3, which is 2 root 3. Now if you will notice, the previous example, when we had the length of the side as 1, we came up with the length of the diagonal as root 3, or in this case we can say that it is equal to 1 multiplied by root 3. 1 is the length of the side. And in the second example, when when we had the side of length 2, we came up with the diagonal as 2 multiplied by root 3. So 2 is the length of the side again. So in general, we can conclude that if for any cube with the side, any cube with side length equal to n, side length is n, we can say that length of the diagonal is equal to n times root 3, n multiplied by root 3. You can certainly try it for n is equal to 3, where the length of the side is 3, and see if this works, and try to find out using the same principles of Pythagoras theorem to find out if n is equal to 3, if the length of the diagonal is 3 root 3. It certainly should apply, but you can do it as an exercise in your free time. And this explains certain examples of how Pythagoras theorem can be used to calculate distance between 2 points given the length of the other 2 sides.